In these lessons, let's look at how you can capture a wireless frame in a Linux operating system. So Linux is one of the easiest operating system to put an adapter into monitor mode. In this particular method, I use Wireshark as the sort of application, and then simply put my wireless adapter into monitor mode to demonstrate the packet capture capability. There may be other sort of options available as well. So there are many different ways, but in here we are only looking at the one option there. First of all, you have to basically find out what is your physical interface assigned to the wireless adapter. Using iwdev command, you can verify that. And then you have to basically create a interface in monitor mode. So typically wireless adapters by default in manage mode. So how can you create a monitor mode interface? You can specify the physical interface, and then you can give any name, and you can add the interface and type monitor mode to be used there. And then you can delete your like existing manage mode interface, because we are not using that manage mode interface here. And then what you need to do is basically you can bring your monitor mode interface up, and then you have to set the channel to be captured. So for your wireless monitor mode adapter, how can you do that? You can basically use the iwdev set frequency command. In this command, you expect to give the control frequency. That means what is your primary channel, and then channel width, and specify the center channel. Sometime when you're using a 40, 80, 160 megahertz, it's important to specify where your center frequency is. Specifically in 6 gigahertz, it is using a different primary channel, not the first channel available when channel bonding happen. It's typically use the second 20 megahertz. In that way, keep it in mind. So now how can you calculate those center frequencies? In here, I have given an example. So now my test scenario, I have access point in these three channels. Channel number 1 in 2.4 gigahertz, and channel number 149 in 5 gigahertz, and channel number 21 in 6 gigahertz. So center frequencies, if there are some simple formula. So in the 2.4, center frequency calculated 2407 plus 5 times the channel number. So if I am using channel number 1 times 5 is 5. That means 2412. So center frequency will be 2412. So now 5 gigahertz center frequency is calculated 5000 plus 5 times the channel number. So now if I am using channel number 149, my center frequency will be, like a primary channel will be a 5745. That is the control frequency. But if you look at the center frequency, that's the middle of that is 5775 will be the center frequency. Now 6 gigahertz, I am using channel number 21. The formula is 5950 plus 5 times channel number. So now in here, center frequency will be 21 times 5 is 105. And you adding 5950, that will be 6055. That is channel number 21. So now if you worked out the center frequency, you can see it is 6065 is the center frequency. That means when the set frequencies, so to capture this channel, you need to use those set frequencies and the channel width, and like this. Now let me just go to my Linux environment and show this. So here is my Kali Linux environment. So now if you check iwdev, you can see now I have 3 interfaces. So those 3 interfaces, WLAN 0, WLAN 1, and WLAN 2. So all of them are by default in manage mode. Okay. So with the manage mode, we cannot take packet capture. So what you need is a monitor mode interfaces. So remember now file physical interface number 7 assigned to WLAN 0, 10 and 11 to 1 and 2 WLAN interfaces. Now, how can you create a monitor mode interface? You go with that command, sudo iw5, and then 57 is the sort of my interface for WLAN 0, I will create interface add. I will use MRN 0 as a sort of my monitor mode interface and type monitor. And then for the other interface, the physical interface will be number 10. That's my physical interface assigned to. And I will create interface called MRN1 in that. And then I will create MRN2 with physical interface 11. So now I have created 3 interfaces, all monitor mode. So now what you can do is I can go ahead and delete the manage interfaces because I don't want to use those manage interfaces. How can you delete? Sudo iw, you can say delete a device and WLAN 0, delete, and then WLAN 1, delete, and WLAN 2, delete. Now if you look at iwdev, you should have now clean 3 monitor mode interfaces, monitor mode, and all of them MRN 0, 1, and 2. So now the final step is you can bring this interface up and then assign the center frequencies. So how can you bring the interfaces up? You can go to sudo ifconfig MRN 0 up, and 1 is up, and 2 is up. I bring all these 3 interfaces. So now let's set the center frequency. Sudo iwdev, and you can specify your interface MRN 0 and set frequency. Now I will put the first interface into 2.4, channel number 1 to 412, center channel width is 20 megahertz. And then the MRN1, I will put 5945, which is channel number 149, 5745, and 80 megahertz, and 5775 the center frequency, and 6 gigahertz channel number 21. In that way, channel number 21 means 6055 is the primary channel. 6055 is the primary channel, and 80 megahertz, 6065 is my center frequency, because now primary channel is the second 20 megahertz. Okay. In that way, now once you do that, now all settings are done. Now if you go to again iwdev, you can check all these frequencies set, channel number 1, channel number 21, and channel number, okay, I think I have made a mistake here. My MRN 0, MRN 2, I have the still same, because I have not typed the right number here. I made a mistake there. So now I will go ahead and do MRN 2. MRN, probably let's make like MRN 2. In that way, this interface will be capturing the 5 gigahertz. Now iwdev, MRN 0 capturing channel number 1 to 2.4 gigahertz, MRN 1 channel 21 6 gigahertz, MRN 2 capturing the 5 gigahertz. Okay, now let's go to Wireshark. Just enable Wireshark. You can, now whenever you go to Wireshark, you can see all these 3 interfaces appear in the monitor mode. You can hold the shift button and select multiple interfaces and say go ahead and start capturing the packet. Now you can see packet being captured. So what I can do is I will go ahead and connect my test client. So let me just show here. I had a test client here. Now I have a MRN guess, and this is the Wi-Fi 7 connection. Let's basically connect this as well. Now I'm connecting to PSK and then I'm connecting to .1x as well. Let's simulate couple of connection. I'm connected to .1x and my MRN guest as well. Let's connect. Now I simultaneously simulated 3 different clients. So now what I'm going to do is I will minimize that. Now let's go and stop this capture. Now let's see whether we able to capture those 3 client association. So how you can verify, same logic, go to association request, and you can see I try to connect my client to 3 different SSID. You can see all these 3 captured. So now if you want to check individually, so this is the Wi-Fi 7 connection. Initially I'm connected to PSK SSID. You can copy this MAC address, copy this value, copy value, and go to your frame filter and change your frame filter MAC address with my client MAC address. Now with that, you can see here, my client trying to connect, SAE authentication, association request response, and 4-way handshake. This is WPA3, but if you look at the association request frame, you should see this is a multi-link connection. There should be a multi-link element here. You can see it's a multi-link element there. Power station profile and everything is there. This is a Wi-Fi 7 connection. Now that's the first connection. And if you want to check the .1x SSID, you can check the same thing, but you need to filter the right MAC address. So now this time we are not using a link specific address, like this is the client MAC address, no Wi-Fi 7 here. Now copy the value. Even the guest SSID, same MAC address, we should be able to see both in this particular filter, this option. Now I filter these 2, and now initially I connected, but if you scroll through, you can see .1x kind of process is authenticated, associated, EAP exchange, and then EAP success should be there, and followed by 4-way handshake. So this is .1x scenario, and then a bit later you should see he's connected to the guest SSID. You can see association coming to the guest SSID. In this particular time, you will see he's doing OWE, Opportunistic Wireless Encryption. Let me just confirm it to you. In the RSN element, if you look at the association request frame, client should tell which method he want to connect. You can see here he's using Opportunistic Wireless Encryption. Okay. In that way, you saw it is very easy to take packet capture. Only thing is you need to remember those few commands, how to convert adapter into a monitor mode. That's pretty much it, In that way, that's how easy to take packet capture in Linux. So we will look at a different method in the next video.